random variables from probability distribution. Let S be a sample space. Let S be a sample space. A random variable X is a function with domain X and range the closed interval 0, 1. So a random variable will associate to any outcome of a random experiment a number between 0 and 1. Example, a coin is tossed. You toss a coin, let head goes to 1 and tail to 0. Then the random variable is X equals to 0, 1. So what we did is simply make head 1 and tail 0. Then we get a random variable because we have transformed an outcome of a random experiment into a number. A die is rolled. Let X be the number on the die. This is a random variable. The values of X are 1, 2, 3, 4, 5, 6. This one, we just take the number that is on the die. Three. A coin is tossed 3 times. Let X be the number of heads. Then X will be 0, 1, 2, 3. Remember, when you toss a coin 3 times, you can have head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head. And in each of these outcomes, you may want to count the number of heads that you have. Here you have 3, here you have 1, here you have 0, here you have 2. Those are the possible number of heads that you get if you toss a coin 3 times. The die is rolled until you get number 1. You want to roll a die several times until you get number 1. And X be the number of rows. The number of rows. How many times will you roll a die before you get 1? You can say X is, you can roll 1 time, and you get 10. I'm sorry, and you get 1. You may fail to get it the first time and get it the second time. Or the third time, and you can get, you might roll the die 1,000 times. Maybe, maybe not, and before you get 1, you cannot tell how many times. So these are examples of finite random variables. This one is an example of infinite random variable. This random variable is infinite, but it is discrete. You can count 1, 2, 3, 4. I can say that I want to take a sample of 30 people and get the average income from the 30 people. Then this is a random variable. Because if I get a random sample of 30 individuals from a population, that is a probability experiment. One will say I make 30,000, another one will say I make 300,000, another one will say I make 150,000, another one will say I make 45,000, and then I take the average of their income. And I associate to each outcome. My outcome is a random sample, and to each of that outcome, and I can associate a number, which is the average amount of money. Or the mode. Or I can take the median. I can take the standard deviation. This is how we try to connect probability to statistics. Some random variables might not be discrete. For example, the time it will take us to complete a task. How long will it take before you finish studying? You may not know. It is time, and time is continuous, so it can take any value, even square root of 2 or pi. So this is an example of continuous random variable. So on your PowerPoint, you will see more examples of random variables. Like a student is waiting for a bus. Let t be the time until the bus arrives. This is a continuous random variable. So when we have a random variable, the immediate question we have is, can we define a probability associated to the values of that random variable? We call it probability. Is a function that associates to each value with a random variable a probability. Yes. If the random variable x is discrete, as is in the case in this chapter, the random variable is discrete, then we will have the probability distribution function is a probability on the sum of all those probability, which is P of x1, should be 1. So the characteristic of a probability distribution is that it is a probability. That's a number between 0 and 1. And the sum of all of the probability is 1. For example, find the probability distribution of the number of heads when a coin is tossed. So when a coin is tossed, you can have tail or head. The number of heads when a coin is tossed is either 0 or 1. 0 is probability half. 1. This is the probability distribution. This is our first example. Second example. A coin is tossed 3 times. Find the probability distribution for the number of heads. We are thinking now about this example. And this is the sample space. From that sample space, we are going to define a probability associated to the number of heads. So look at this sample space. Think about each time we get this number, and we want to determine the probability associated with each of the numbers. So what is the probability that we will get no heads? After tossing the coin 3 times. No heads. Now the outcome is a head. I toss a coin 3 times. What is the probability that I don't get a head? Think about the outcomes, they are there. 1 over 8. Thank you. What is the probability that we will get 1 head? 3 over 8. 2 heads. This is the probability distribution for the number of heads when you toss a coin 3 times. Let's think about rolling a die. The die is rolled. Let's give the number of the die. The number of the die. Probability distribution of X is one, 2, 3, 4, 5, 6. Each of the number has probability 1 over 6. Now let's think about this one. Oh. The dice roll until we get number 1. What is the probability distribution of the number of rows? We know that the number of rows are 1, 2. So to compute this probability distribution, we want to know that we want to find the probability for each time we get 1. We get 1, for example, probability that x equals to 1 is the probability that you have roll 1 on the first try. And what is that probability? What is the probability that x equals to 1? 1/6. Probability that you get 1 when you roll a die is 1/6. Now, what is the probability that x equals to 2? That is, you roll twice before you get 1. First is not 1. Second is 1. First time you don't get a 1. And the second time you get a 1. Knowing that these events are independent. So this will be probability that the first time is 1, is not 1. Times the probability that the second time is 1. What is the probability that the first time is not 1? Pardon? You roll a die and you don't get 1. 5/6. And now 1/6. So this is let's look at it when x equals to 3. Probability that x equals to 3 means you will roll 3 times before you get head. That means the first time, before you get 1. That means the first time you fail to get 1, the second time you fail to get 1, and the third time you succeed. So we are going to say it's equal to probability that first, not 1, second, not 1, third, which is probability of first, not 1, second, times probability of second, not 1, and probability of third. So you can see this is 5/6 times 5/6, which is 25/6 raised to power 3. We can write it as 5/6 squared plus 1/6. And from this pattern, can we tell what will be x equals to 4? We failed the first time, failed the second time, failed the third time, and then succeed the fourth time. That's the probability for x equals to 4. So instead of writing each of these all the time, we can see that the pattern is that we will fail in probability 5/6 3 times. So in general, the probability distribution of X is 1/6 times 5/6 raised to the power X minus 1. This is an example of geometric distribution. This is a geometric distribution. We can make a table because we will have to find a value for each of them until infinity. So we can generalize it, whatever is the value of X, we get the probability. Just as we did for statistics with a frequency distribution table, we can also make a graph, like a bar graph, with probability. We can also compute measure of central tendency, measure of dispersion. Let's look at the measure of central tendency on averages. Measure of averages. Let X be a random variable probability distribution X is a random variable with probability distribution P of X. And the mode of X is the random value with the highest probability. Here, for example, there is no mode because they have the same probability. Here, the modes are 1 and 2. Here, we can prove that the mode is 1 because the probability are connected in a way that when X equals to 1, we have 1/6. When X equals to 2, you get 5/36, which is less than 6/36, which is 1/6. When you multiply any number by a negative number, you get a smaller number when the two numbers are positive. So the mode for that is 1. The median the random value is called the median of X if the probability of X is less than 1. It's very good. Mode and median is just for you to know what they are when we speak about probability. Now the mean. The mean of X, also called expectation or expected value, defined by mu X or E of X equals to x multiplied by p of x, which is x1 times p of x1 plus x2 times p of x2 plus xn times p of xn. So the mean of a probability distribution or a random variable x is obtained by multiplying each random value by its probability and add them up. Example. Find the expected number of heads when a coin is tossed. Find the expected number of heads when a coin is tossed. When a coin is tossed, we say the number of heads are 0 or 1. With probability half, a uniform distribution. So the expected number of heads, I can even write expected number of heads is 0 times half plus 1 times half, which is now a coin is tossed 9 times. Find the expectation P of x of the number of heads then we will have 0, x, P of x. This is the probability distribution, and P of x is equal to 0 times 1 over 8 plus 1 times 3 over 8 plus 2 times 3 over 8 plus 3 times 1, which is 3 over 8 plus 6 over 8 plus 3 over 8, which is 12 over 8. So the mean of the random variable number of heads when you toss a coin 3 times is 3 over 2. And we get another example. 3. Again, consists of a number equals this one 3 times. You win the number of it. What is the expected profit for the player? So we want to define the profit as G. Then we define the probability distribution for G. The probability distribution for G is so let's think about the game and how we get to a game. How do we get profit? To get a profit, you will roll the coin 3 times. The number of heads you get is your revenue, is what you are being paid. But to play the game, you first pay the $1. So when you play 0, you lose your $1. So you get negative. When you play 1, you win 1, and you get. When you play 2, the number variable is 8. 8. So the expected gain is negative 1 over 8 plus 0 is 2 over 8 plus 2 over 8, which is 8. So the expected profit here is 0.5. You expect to win 50 cents when you play this game. Generally, we say that a game is fair when your expected profit is 0. The game is considered with its expected profit. In cases where your probability distribution is complicated than this, let's try that. The die is rolled until you get number 1. What is the expected number of rolls? How many times will you roll a die before you get number 1? That's our question here. So we are going to say that XB, the number of rolls, the E of X is equal to x times p of x, which is equal to x equals to 1 to infinity. So now look at the definition of our p of x. It will be sum of x equals to 1 of x over 6 times 5 over 6 raised to the power x minus 1. Which is equal to x equals to 1 of x 1 over 6. Most of you did calculus. You know calculus? Somebody here doesn't know calculus? We need calculus to complete this. Somebody that like calculus here? Should we do some calculus for 5 minutes? Somebody to say no if you don't like calculus. No, you like calculus, everybody, right? Calculus is that guy that people are not ashamed to say, I don't like him. Okay, but I will just explain. You see, if you remember calculus, when you have like x raised to power n prime is nx n minus 1. You remember that in calculus? Like if you have x raised to power 3, if you want the derivative, it's 3x squared. You remember that something like that from calculus? Okay, that's what we have here. That's the derivative of 5 over 6 raised to power x. So we use that to continue. But I just wanted you to know that to find an expectation is not always as easy as for a finite case. When you get to infinite case, you want to think about some better method of doing the computation. So now, let's look at measure of variation of a probability distribution. Of variation. And x be a random variable with name E. The variance of x denoted by sigma square x, or variance of x, is sigma square x is equal to variance of x, which is the expectation of the square of the deviation from the mean. This is the expectation of the square of the deviations from the mean. Remember, we said that the population variance was the average of the square of the deviations from the mean. That's the same principle that we use in probability, which is equal to sum of x minus mu squared times probability of x. But we are not going to use this formula. We are going to do some small proof here because this is my 215. So my 215, sometimes we will do some small proof. So if you don't like the proof, don't worry. It's just part of making the knowledge you have acquired in calculus here more consistent in your mind by seeing how you can apply it to some other concepts. So remember, the variance of x is equal to the expectation of x squared minus the mean squared. So the variance of x, the way we define it there, is the sum of x minus mu squared and probability of x. Mu here is the mean. And the mean is a number that we know. It's not a variable. Mu, the mean, is not a variable. So we are going to expand this to x squared minus 2x mu plus mu squared is this one, plus p of x. Which we can write again as sum of x squared times p of x minus 2x mu times p of x plus mu squared times p of x. So when you are applying the sum, so the sum has a property which is called a distributive property of the sum, or the linear property of the sum. So this sum will apply to this one, then apply to all of this, then apply to all of this. So we are going to rewrite this as equal to sum of x squared times p of x minus 2 times x mu times p of x plus mu squared sum of p of x. What I've done is I put the sum in each of these terms inside. Now this guy here is e of x squared. If you look very well, is the expectation of the square of x. The expectation of a random variable is x times p of x. So this one is x squared times p of x is the expectation of x squared. Now here, this mu is a constant, so we can take it out and write this as x times p of x. And this one is mu squared, because we said at the beginning that the sum of all the p of x is always 1. The sum of all the p of x is always 1. So this one will become e of x squared, and this guy is e of x minus 2 mu. Now e of x is the same thing as mu, so this becomes mu squared. This is e of x, or mu. Mu was x times p of x. It might still be somewhere there. Now plus mu squared. So that is why we get this as e of x squared. Mu squared. Well, that is a nice proof. So from now, when you want to find the variance, it's easier to use the second formula, that is e of x squared minus mean squares. So the standard deviation is the square root of the variance. Just as we say in statistics. It is denoted by the sigma. It is equal to square root of variance. So let's do some of these examples. We will use some of these examples. Let's start with the first one. Find the variance and standard deviation of the number of heads when a coin is tossed. This is just once. When a coin is tossed. I start with a simple one. We have 0, 1, x, p of x, half, half. What was the mean? Do you remember what was the mean here? This time it is plus that time. So the mean is half. So I'm going to complete this one with x squared. X squared here is 0 and 1. You square each value, you get this one. So the mean of x squared is just 0 times half plus 1 times half is also half. Because x squared, in this case, x squared is just the same as x. So the variance now will be e of x squared minus, you can write minus e of x squared, but I prefer to write minus mu squared so that you don't mix the square where it is square. So this is equal to half minus 1 over 4, which is half minus 1 over 4 is 1 over 4, right? You can put it at the same denominator. Let's do the second example there. A coin is tossed 3 times. This is sigma squared and sigma equals to half. Standard deviation. A coin is tossed 3 times. Find the variance and standard deviation of the number of heads. Here we have a coin is tossed 3 times. It's no more just once. So the random variable here is 0, 1, 2. This is 1 over 8, 3 over 8. To find the variance, we have x squared. The regular method of finding the variance is to subtract the mean from each value, square it, and multiply by the probability. Then add it up to get the variance. Take the square root of the variance to get standard deviation. That's what you will see as one of the examples in your PowerPoint. I'm not doing that one now because it will take us some time unnecessarily. It is just the same result you get. So here we know mean. In this example, we said the mean was 3/2. Now, what is the mean of the square? You don't want to forget the mean of the square. So to find the mean of the square, I square each value, multiply by the probability, 0, 1, 4, 9. These are the square. I will use the same probability because I just squared it. So I will have 0 times 1/8 plus 1 times 3/8 plus 4 times 3/8 plus 3 times 1/8, which is 3 plus 12 plus 3/8. Yes. No, I'm sorry. 9 times 3. Thank you. 9, this 9. I'm multiplying this times that. I hope you all understand why it's 9, not 3. I was having the 3/8, 3/8. So this will give us 24/8. Which is, if you divide this by 4, anyway, by 8 is 3. Having that, the variance will be E of x squared minus mu squared, which is 3 minus 3/2 squared. This is where you make mistakes sometimes. Forget to square this. 3 minus 9/2, which is 12 minus 9. Standard deviation. So each of these examples, we can use it to find the mean and the standard deviation. I'm going to do one more example. I will leave a little bit of the type that we are doing, which is result of a game or something that we. Let's just take a general random variable. Find the mean, variance, and standard deviation of the following distribution. Let's call it y. It is not supposed to be always x. I'll put here That means I can say negative 1, 0, 1. Here, 1 over 5, 2 over 5. So I made this up. All what I want is to make sure that each of these number is between 0 and 1. And when I add it up, it gives me 1. Then the mean will be negative 1 times 1 over 5 plus 0 plus 2, which is 2 minus 1. The mean of the square will be negative 1 square plus 1 over 5 plus 0 square plus 2 plus 1 square plus 2. So this will be 1 over 5, 2 over 5 plus 2. If I have that, then the variance will be x squared. Your x squared here is 3 over 5. Mu is 1 over 5, which is 15. Here I will put its common denominator to be 25. So it's 5 times this, just like I multiply here by 5. I have 25 here and I subtract 1. So this is 14 over 25. The variance is 14 over 25. Standard deviation, square root of 14 over square root of 5 of 25, which is 5. I just want you to see that you can get any distribution and you are asked to find the variance, the mean, the variance, and the standard deviation. We can stop here. First thing we are going to look at some linear property of our neighborhood of expectation actually. And we are going to learn about some of the tangents.